Okay. All right. So aloha and good afternoon. Welcome to today's webinar, where we will be covering the determining indicators of pasture health protocol for use in conservation planning in the Pacific Islands area. My name is Carolyn Wong. I'm your state grazing land management specialist for USDA NRCS. And joining me today is Elena Dosamantes, a range technician that works with me here in Waimea, and Jedediah Dunn, our new area resource conservationist. I'm really excited to share this new tool with y'all. It was just released earlier this year, and it's very similar in design and function to interpreting indicators for range health. Some of you may be aware that last year I was trying to work on figuring out how we could adopt range health for use in conservation planning here in the islands. And as I was doing that, I caught wind that they were coming out with this tool, which opportunistically turned out to be going in the same direction that I was headed with the IIRH in incorporating several additional indicators that will help it to work better on our naturalized pastures. So as I said, it's very similar to interpreting indicators of rangeland health, as it seeks to assess grazing lands from more of an ecosystem health perspective. It also incorporates elements of pasture condition scoring. A few years ago, some of the folks out of our National Grazing Lands Leadership Team recognized that we had a need for an integrated assessment tool for assessing grazing land health on both pasture and range. And I really believe that this tool is an effort towards that goal. This assessment has also been incorporated into CART and planning criteria, and it's in the process of being incorporated into the new version of the National Range and Pasture Handbook, which has not been released yet. This tool is meant to be used with ecological site descriptions, but it can also be used without them. And until ESDs are available to us here in the islands, it'll be important that users of this tool have familiarity with the grazing land type that they're working in, or request assistance from someone that does. Before we dig into the tool, let's recap briefly on our grazing land definitions. The National Planning Procedures Handbook defines pasture as land composed of forage species that is used primarily for the production of livestock. Pastures also receive periodic agronomic inputs or treatments as listed here. The NPPH also defines range as land which is predominantly grasses and such that they are managed as a natural ecosystem without the agronomic inputs that pastures receive. Some of our grazing lands here in PIA fit pretty nicely into one of these two definitions, but there are a lot of lands that fall into the gray zone. The gray zone. Actually, a lot of our grazing lands here in the PIA are best classified as naturalized pasture, which is defined here for us from the National Range and Pasture Handbook. Much of our grazing lands were once forest, but they have been changed, either due to a cropping history or loss of trees by harvesting or other disturbances, and now support voluntary stands of naturalized vegetation. All right, you might be like, naturalized pasture, we don't have that in desktop, and you're very right. This table summarizes actual land use descriptions here on the left for what we see on the ground and the technical definitions that we have available to us. And then I added a column for what we have to call those land uses in desktop. So if it's pasture, if it meets the pasture definition, it's pasture in desktop and you can move along. If it doesn't meet the pasture definition, if it fits better under the naturalized pasture definition or the range definition, then in desktop we have to call it range because of how it's managed. Now we have two assessment tools available for use when the land unit is identified as pasture. You can use either a pasture condition score sheet or the determining indicators of pasture health. We're all familiar with the pasture condition score sheet, and that tool can still be used. It's no problem as long as it's used on lands that meet the definition of pasture. The DIPH can also be used, and the results of either of those tools can be reported in CART, no problem, but only for land units identified as pasture. For the Pacific Islands area, land units that fit the range or the naturalized pasture definitions and have to be called range in conservation desktop will be evaluated using this DIPH tool. As it is so similar to interpreting indicators of rangeland health, the results can be inputted into CART as the outcomes of rangeland health. As it incorporates several pasture indicators, it should work better in the field to be better suited than the original rangeland health protocol, especially in our wetter areas, our wetter naturalized pasture plant communities. I heard a bing. What did that mean? I can't see my my team's presentation while I'm doing this, so if y'all need something, unmute yourself and say, excuse me. Okay.
Someone just needed admitted, so I admitted them.
Oh, thank you. Okay. All right, next slide. Okay, so that's just a real quick touch on our definitions and where this new tool fits into the planning process. Now, getting into the tool. The DIPH protocol is intended to be used by people who are knowledgeable and experienced with the protocol and the ecological system being evaluated. Now, that can come by either formal training, which I hope to do with all of you in the field, working closely with others who have training and experience. It's also meant to be used to provide a preliminary evaluation of the attributes of pasture health. It's also useful for communicating fundamental ecological concepts to a wide variety of audiences. It can be used to improve communication by focusing discussion on critical ecosystem properties and processes. And it's also very beneficial to assist land managers in identifying areas that are at risk of degradation and where resource problems or management opportunities currently exist. All right, so you all know Hawaii is a very diverse landscape. Soil and plant variables are different across the continuum of grazing lands that we have in the PIA. This map here in the middle is a map of all of our different MLRAs, many of which have naturalized pasture plant communities within them or non-native range. Some of our environments are capable of sustaining high species diversity and many different adapted forage species, including legumes, and soil biota, such as earthworms, are plentiful, while some pasture systems are limited in these respects by various environmental constraints, usually and mostly rainfall. For example, a wide variety of cool season grasses and legumes may be grown and maintained successfully in our humid, cool climates on the Big Island and parts of Maui, whereas some of our warmer subtropical climates like Ho'olehua or Kahuku or many of the areas on Kauai might only support a maximum diversity of maybe one warm season pasture grass, primarily guinea grass, and then maybe a woody legume or possibly a vining legume. Rating these indicators should be evaluated within the ecological constraints associated with the ecological site. As our ecological sites are developed, and reference sheets that describe site potentials within ecological constraints will certainly be made available. Until then, we can use the DIPH when ecological sites information is not available by using the evaluation matrix included in the tool. Okay, so DIPH evaluates 3 ecological attributes and 1 management attribute. The 3 ecological attributes assess how well ecological processes, such as the water cycle, energy flow, and nutrient cycling are functioning at a site. Soil site stability is describing the capacity of an area to limit redistribution and loss of soil resources, including nutrients and organic matter, by wind and water. It also refers to the ability of a site to recover this capacity when reduction does occur. Hydrologic function is the capacity of an area to capture, store, and safely release water from rainfall, and as well as resist a reduction in this capacity or recover this capacity when a reduction does occur. Biotic integrity is the capacity of the biological community to support biological processes within the natural range of variability expected for a site, and then also to resist the loss in the capacity or to recover that capacity if losses do occur. The biotic community includes plants, animals, insects, and microorganisms occurring both above and below ground. Lastly, the livestock management quality factor. This factor refers to the ability of an area to support a sustainable livestock grazing operation and is a new contribution to the list of attributes. This attribute incorporates elements of grazing management and the suitability of the current plant community for livestock production. Management interpretations based on this attribute are based on the ecological potential of a site. All these attributes are determined by evaluating specific indicators in the field. Lots of new language, I know, just hang in there with me, okay? So the 4 attributes you can see listed here at the top of this table. We assess these 4 attributes by evaluating 22 individual indicators in this tool. Actually, for PIA, we're only going to assess 21 because number 16, annual production, will not be assessed for PIA. As you can see from this table, each indicator tracks to one or more attribute. You can see sheet and reel tracks to both soil site stability and hydrologic function. Infiltration and runoff tracks only to hydrologic function. Soil surface loss or degradation tracks to all 4. So does a compaction. No, I think that's actually a typo. I'm sorry. I think these, anyway, it's correct on your data sheet. And I don't have that in front of me right now, but it's correct on your data sheet. Pardon me for this slide. But basically how to interpret this table is that each indicator overlaps the assessments, the attributes that they track to. Okay. Many of these should look familiar because some of them come directly from Pasture Condition Score. And we are going to discuss each of these indicators in this presentation. Okay, so earlier I sent out the evaluation matrix in the DIPH tool and encourage you to print it. This is a clip of what it looks like, a portion of it. The DIPH tool uses a matrix which describes each indicator as they may appear on the land within a range of departure from normal or from the optimal or potential site conditions that would be described in a reference sheet. You will note at the top of the matrix, starting from the far right, the departures are described as none to slight, slight to moderate, moderate, moderate to extreme, and extreme to total. These are departures from the reference or healthy condition. So the worse off a situation is, the more severe the erosion, you'd be more on the extreme to total side of the table. And if there's no erosion, then you'd be in the none to slight side of the table. So those 5 departure categories are described for each indicator. The circles here indicate and are just put in there as an example of how when you're assessing a site, you're selecting the description that matches the site the best. So for indicator number 1, for example, sheet and reel erosion, a site that has no evidence of rills would be rated as none to slight. And for number 4, a site with a stream bank that is being trampled and showing signs of negative impact because of grazing, that would be rated as having a moderate departure. On page 2 of the evaluation, if you enter your results on the computer, as you enter the ratings for each indicator, those ratings will automatically transfer the number of the indicator to the appropriate attribute table at the bottom of the data sheet. Of course, this can also be done manually on a paper copy of the data sheet. On the data sheet, you have the list of indicators here on the left, the summary of which attributes each indicator tracks to, a place to note your rating, and a place for notes. Because 1, 2, 3, and 4 are tracking to both soil site stability and hydrologic function, those are the only 2 attribute tables at the bottom that they transfer to. You'll notice they did not transfer to biotic integrity or the livestock management quality factor. If we had a indicator rating indicated here for forage plant diversity, the indicator number 13 would transfer over here in these 2 tables according to the rating that it was given. The number 13 would show up in the appropriate column. As you use this tool, it'll make more sense. Okay, so yes, and again, you can see there's room for notes here on the side, and I highly encourage that you just make a quick note about the field condition and what you observed that influenced your rating, and just jot it down in there. It'll come in handy later. Once all the indicators have been rated, the suite of indicators related to each attribute are considered collectively to determine the overall attribute's rating based on what is called the preponderance of evidence. This part is not automatic. As the planner, you consider the results of your evaluation and the evidence and make the determination. So in this example, for soil site stability, we have a majority of indicators are rated here in the none to slight column. There's a couple in the slight to moderate column, and there's one rated as a moderate. As a planner, consider what those higher rated indicators are. Number 4, recall, is stream bank erosion. If this represents a really small part of the larger land unit, perhaps it's really not very weighty. Consider those rated as slight to moderate. Are any of those significant? Are they affecting the soil and its ecological role in the health of the site? Based on the evidence, perhaps a none to slight or a slight to moderate overall rating might be appropriate. You'd apply this same process to assess hydrologic function, biotic integrity, and the livestock management quality factor. Consider the indicators, step back and consider the bigger ecological attribute, and then assign a rating. Use the note box to record your rationale for each attribute. This is a part some people really struggle with. And so if this part is really, really difficult for you and you're not really confident in making a call, especially when you have things that are spread out so much, like in this example in the biotic integrity, I'm taking a great suggestion from Jed, and we're going to adopt as a rule of thumb that we assign the highest rating at which you have at least 3 indicators at that rating or higher. Okay, so if we were to apply that to this biotic integrity example, that we're going to assign the highest rating that we have at least 3 indicators at or higher. So if we started here when counting number 16, 19, and 17, we have 3 indicators at or higher the moderate departure category. So we could, using the rule of thumb, we could assign a moderate overall rating to the biotic integrity if you do not feel confident in making the call. Now, if you feel like you can confidently assign something either higher or lower based on your professional opinion, go for it, but record your justification in the notes box. There is a Survey 123 app, a tool that has been developed for the interpreting indicators of range health. And I am advocating that we will see, I'm advocating the designers of that to make determining indicators of pasture health added into that app, which would allow completion of this tool on a smartphone. We're not there yet, but I'm being very persistent in asking that might be possible. In addition, as Elena shared in her meet and greet, we are also working with the team at the University of Arizona, and we've already sent them this new tool, and we've asked them to incorporate this protocol into VGS, which we hope to have available on mobile devices soon as well. Okay, so now that we have an idea on what this protocol involves, here are suggested steps to implement it successfully. First, preparation. You need to get familiar with the grazing operation and the landscape that you'll be assessing. You want to have an idea on its boundaries, what the landscape looks like. You want to get the soils identified and start to identify any different pasture types or ecological types sites that you might have out there. Step 2, identify potential evaluation areas. Each evaluation area should be within a single ecological site, be relatively uniform as far as slope, aspect, disturbance patterns, etc., and large enough to accurately evaluate most of the indicators. A good rule of thumb is you're shooting for about a 1/2 to a 1 acre area that you'll assess in the field. Step 3, when available, obtain the ecological site description reference sheet and evaluation matrix. When those are completed, they'll be written specific to that area and will give you a more detailed evaluation matrix with which to compare. Step 4 is you'll collect any supplemental information that might help you in doing your assessment. So you might want to look at what's the recent rainfall data been for the area. You can access live, rainfall gauges online. You might gather information on the disturbance history of a landscape, what type of land treatments it might have received, etc. And once you've established that, also ask you to consider the timing. Timing is an important factor in conducting this assessment because Ideally, you'll conduct it when the indicators are accessible and readily observed, preferably during the growing season. Some parts of our state are more seasonal than others, so in some places it'll matter more. In other places, it's the same almost all the time, so kind of take that into consideration when you're preparing. Once you're ready to go to the field, here's a quick brainstorm on field equipment checklist that you might want to consider, making sure that you have the proper equipment in the field. Nothing worse than getting to your site and realizing, oh no, I forgot my penetrometer, or I forgot my shovel, or I didn't bring my grass clipping equipment. Don't ever forget that. Step 5 is get to your identified evaluation area and establish it. Be sure it's representative of the larger area or land unit, and go ahead, walk around and explore it. Really important that you don't try to conduct this assessment from one single location, but really move around and and take a look at the landscape, take a look at what's going on, and then start to rate the 22 indicators. After you've rated the individual indicators, step 6, either in the field or in the office, transfer those individual indicator scores and assess the 4 attributes. Okay, that was a lot. Any questions so far? Feel free to unmute yourself and speak up.
Don't be scared.
I know that was a lot. I just hosed you with a fire hose. Don't worry, I'm gonna plan time to come out with each office. Just you let me know when it works for you. Line up a few of your pasture plans and we'll go out and practice this together. It's really important for me that you feel comfortable and confident doing this. Jed also has experience with the range health protocol, which is so similar to this that I know he's not going to have a problem as far as how to implement this. I understand that our new DC on Maui also has experience with the range health protocol, and we're available. So just schedule some time with me. I would like to take some time with each office and just ensure that you all are comfortable with this tool. All right, well, we're gonna jump into the indicators, but before we do, just a little teaser here, little advertisement preview coming soon. Elena and I are working on wrapping up Range and Pasture Tech Note number 5, which will be a determining indicators of pasture health guidance document. It will include several of the steps that I just described in this PowerPoint, as well as have more thorough information than there will be in the slides of this PowerPoint. We're gonna have more thorough information for each indicator, and it'll be formatted to be easy to print, stick in a binder, add it to your field bag. So when you go out to do this, especially in the beginning, you can have some of that supplemental information to help you along. Okay, so we'll move on into the indicators. And I just want to thank Jed and Elena again for helping me with this presentation. I'm so grateful that I don't have to talk through this whole thing. And so with that, Jed, when you are ready.
Yeah, and I would also add maybe something you might want to do is maybe a quick run through of that tool. We could either do it now before we get into it, or maybe run through it at the end, the actual Excel document.
Sure, I can bring that up real quick.
Okay. So they can see what they're working with.
Yeah. Yeah, if y'all haven't opened it yet, here it is. Can you see that, Jed?
Yeah, I can see it.
Okay, super. So in this Excel document, you'll see that we have 4 tabs at the bottom. The first tab is a overall evaluation sheet data form that helps you record where you did your evaluation, what it represents, etc. Gathering some of that background information. Really helpful to have this if you ever are going to go back and evaluate it again. We're also working to get the rangeland hydrology model calibrated for Hawaii. And so if you can jot down some of your observations on this stuff, that would be really helpful as well. But it's optional, this bottom part. Page 2 of the evaluation is the actual worksheet where you will record your ratings. This can be printed and taken to the field, or it can be completed electronically, either way. As I was saying, these have pull downs. And so as you identify the rating for these different indicators, it will automatically transfer the number of that indicator down to these tables in the appropriate column. So I gave it a slight to moderate rating. It's recording it the number 1 in the slight to moderate column in soil site stability and hydrologic function. Let's take another one here. If I give this one a none to slight, then it will record number 11 in the none to slight column across the 3 attribute tables that indicator tracks to, and that's indicated by these columns here. That's what this all means. So each of these, as you populate them, they will record the numbers down where they should be, and that's how we move along. So it's really pretty slick. I stole this this worksheet from a gentleman in Colorado, Josh Tahiro, who's a real whiz. He created this and made it so that these numbers will automatically transfer the way they do, and it's made it really, really easy. Just as a reminder, number 16 is in, I left it in the form because I want this form to look as similar to what the national form is going to look like. But for PIA, because estimating annual production is, nearly impossible, I talked with the National Tech Centers and I got some support from all of them as in my rationale for not conducting that assessment for PIA. The third tab is your matrix. It'll print out front and back on a single page. It should. And I encourage you to have these handy as we go through the slides. It'll be nice if you can take a look at what these different departure categories read like. And then finally, for your convenience, I've just got this field equipment checklist from the spreadsheet, from the PowerPoint. I plopped it in here and saved it as well. So this should be what your Excel file looks like. And this will be filed permanently under the range and pasture tech note number 5. Within a week, we should have it posted there on the website. Okay, one more time, any questions? Okay, hearing none, Jed, the floor is yours.
Excellent. I want to start off with an experiment. I want to see everybody hit the hand button and see what happens. I want to see if it's visible. Cool. All right, you can put your hands back down. If you know how. All right. So we're going to start off with indicating pastures of range on health with erosion. So number 1 on the sheet, rill erosion. So rill erosion generally happens whenever there's a loss of soil site stability. This could be from overgrazing or many different things. Rills and gullies can have similar formations. Rills generally will only follow one plane. Let me turn my camera on. So what I mean by that is it'll be on one slope. And so the rills will be going down one slope. And when you have gullies is when you have intersecting planes of erosion. The gullies will generally form inside those 2 planes. And so those will be your deeper formations. Another general guideline to follow, differentiating rills from gullies, is definition by Shelby. Less than 1 foot wide and 2 feet deep, those would be a rill. If it's deeper than that or wider than that, then that would be a gully. So I'll actually do the reading. Rills are small, intermediate. Yeah, I already covered that. Just next slide, actually. I think that's pretty good, since I can't click. So this is a good picture of rills right here. And so I want to do a little test with everybody. This is why I asked for the hand raising. Everybody raise your hand if you think this is, let's start off with none to slight. Okay. Slight to moderate. All right, got a couple. And moderate. Everybody's agreeing with moderate. Moderate to extreme. And extreme to total. Are the hands up still saying extreme to total, or did you guys leave them up for the last one? Okay. I wouldn't call this one extreme to total. There'll be an example of that, I think, in a few slides. This one I would probably fall with the moderate category personally. What would you say on this one, Carolyn? I don't think it was actually on this slide, but
You caught me with my lunch in my mouth. I'm sorry. I voted for moderate based on what we can see. Rills are at least moderate in number and at infrequent intervals, moderate with a moderate width, depth, and length, and it says occurs mostly on exposed areas. I really was torn between moderate and moderate to extreme, because moderate to extreme says occurs in exposed areas and in some adjacent vegetated areas. And so I could have, I was kind of wavering between the two.
And it would be interesting to see it when it's not wet like that, because it looks to me like those could have formed, where a lot of them do form is through cattle trailing, when you get that compacted soil layer and that disturbance. And so that'll kind of start some of these sometimes. So it'd be interesting to see if, because the one over by the tree definitely looks like that, but the others, yeah, could be forming where there's no disturbance.
Yeah, totally. So it could have gone a couple of different ways. And with all of these pictures, we're just seeing a snapshot of a small area. So, you know, we want to take a look at the rest of the area and make sure it jived with what we were considering. Okay, next slide.
Yes. I'm still seeing the same slide.
Okay, sorry, working on it.
That's okay.
There we go.
I wasn't sure if it was my computer or...
You should be seeing the gullies.
Yep, I got it now.
Okay.
So gullies, as I went into, are more well-defined, and they're going to be a lot bigger than the rills, and they're going to be more in those areas where you're getting the heavy water flow pattern. And so gullies aren't necessarily a horrible indicator. It just depends on what the gully looks like. If the gully is an old gully that's been revegetated or something like that, that's not necessarily something that's happening right now. That's something that happened in the past. And so we'll have some photographic examples of that, actually. I shouldn't have flipped all mine over. Okay, next slide, please. Okay. So this has a lot going on with it. There'd be quite a few other things that are popping up when you're doing this matrix. But you can really see, my mouse doesn't show through, but yeah, perfect, thank you. You can really see where the gully is forming right over there, and it's got sharp sides, no vegetation along the banks of the sides, just at the top where it's precipitous. And so this is a pretty good example of what a gully could look like, especially in, I'm not totally familiar with Hawaii yet, but this looks like one of the drier climate zones, just judging by the vegetation and the trees there.
Yep, that's correct. Next slide.
Yes. We'll do another voting one soon. Just keep everybody awake.
Should have progressed.
It did.
Okay.
All right, so this one's a pretty good picture as well. So there's definitely a lot going on in the background, but there's also a lot going on in the foreground down here by the trees. And so this is, well, let's do a vote on this one. So you'd look at number 2 on your sheet if you guys printed it. If not, I'll read it. So if present, large, deep, intermittent watercourses with steep sides, stable gullies have less steep sides with plants and no active erosion at the head cut top or at the top of the sides. So, oh, let's just be fair. Who thinks it's none to slight? Raise your hand. Jocelyn, your hand is still raised. So I'm going to count you as this vote. All right. Slight to moderate. Moderate. Moderate to extreme. lot of moderates to extreme, and extreme to total. Okay, that's pretty good. You're both on the right side. Pretty much everybody answered moderate to extreme or extreme to total. So for moderate to extreme, that would be intermittent vegetation on banks and or bottom. So that's hard to tell from this picture. Nick points common, moderate active bank and bottom erosion, including down cutting, significant width and depth, which these definitely have, and active HUD cuts, which these definitely have. But just given the scale of this photograph, I would go with extreme to total, which is sporadic or no vegetation on banks, which you can see those even through the picture. Significant active bank and bottom erosion, including down cutting, substantial depth and or width. So these are very wide and deep. And so this one would have been extreme to total. So everybody gets a candy bar next time they actually see me in person. That voted extreme to total. You'll just have to remember yourself. Next slide. Here we go. And so this is what I was saying about gullies not always being significant as far as this goes. This is actually a gully, but it's all been completely revegetated. So this would fall under none to slight. There is a gully here, but it's from a past formation and it's all been completely revegetated. This isn't actively eroding, this is actively rebuilding. So this would be a good example of a none to slight gully. Another example would be nothing, just a nice hill with grass on it. Would be a great example of none to slight. And this can get tricky, but generally I think the size and scale is a really good way to go with this. And if you're dealing with a lot of topography and aspect, be looking for those gullies where you have those intersecting planes. And so that's where you may find something that you will call a gully because it will be more significant and it will be where there's more flow coming through. So it's important to have good vegetation in those spots, especially. Okay, on to wind. What slide number are we on? 23? Upside down.
23. I
got it. I just had them flipped over upside down. Indicators of pasture health erosion. So we're on to number 3. Erosion is highly correlated with major site deterioration and desertification effects. Desertification. Windblown particles cause abrasion to plants and exposed roots. And so this is going to be a large factor, especially when you're in your drier climate zones. And it can progress quicker than you can think that it would. And this one is really affected by management. If overgrazing can cause desertification, and good grazing management can actually reverse the effects of desertification. There's a really good producer in South America right now that's doing some soil health presentations on what he's doing with his ranch and high pasture rotational systems even down there. So they've actually been reversing the effects of desertification. So it's interesting how much what you have out there and how you treat it affects what your soils and what it's going to look like. So next slide, please. Sorry for my tangent. That's just how my brain works. All right. So let's do a vote on this one. So this is a good example of some wind erosion. There's a couple of things that are happening here. There's scouring and also deposition. So with that hint, who thinks none to slight? Raise your hand. That wasn't me raising my hand. That was just an example. Slight to moderate. Moderate. Moderate to extreme. Extreme to total. Lots of people getting candy from this one. Yeah, so Extensive. Wind scours usually connected large soil deposition around obstructions. So you can see where this is being deposited right here. Once again, my mouse doesn't show, but Carolyn can show us. Yep. And just the lack of vegetation is going to give you a great idea of what's going on here. You can really see the movement in this picture of the soil particles. Next slide. Stream bank erosion. So this one, you don't want to get too caught up with defining perennial streams as gullies. So streams are somewhere where water is supposed to typically flow, and your gullies are new formations. So let's go ahead and get to some examples. So this is a stream bank, and as you can see, there's been some sloughing off of the sides. There is vegetation in the bottom, and you can also see vegetation at the top, but you can see the state of the vegetation at the top is pretty mowed down. Kind of looks like a nice putting green minus the rocks. So this one, with those hints, I think there's a couple answers to this one. Who thinks, let's start at the other end. Who thinks extreme to total? With their hands. Who thinks moderate to extreme? Which would be more than half of expected bank vegetation absent, vegetation trampled, sloughing and vertical banks, active erosion, hydrology of riparian systems highly altered. Okay, that's almost everybody. Moderate, which would be about half the bank vegetation trampled, active sloughing and downcasing, hydrology of the riparian system moderately altered. Slight to moderate, some indication of trampled bank, and none to slight. I left my hand up. Oops. I think we put down extreme to total for this slide, but I could also, I'm kind of looking at it again, leaning towards more moderate. Just given that there's vegetation in the bottom and you can kind of see it going up the slide slightly, there's some roots present. It's pretty bad, so I would go with moderate to extreme on this one. What do you think, Carolyn?
You definitely want to, yeah, I agree. And you definitely want to, look at the greater reach of the stream. You don't make a call just on a little section, but this picture just showed that type of damage the best. And based on what we can see, assuming we'd see more of this, I would definitely support a moderate to extreme rating.
Yeah.
Pardon, I have a question about this. So there's places on the island that vary highly with seasonality. I'm assuming we're only assessing what we're seeing in that present moment, despite knowing that that site might fluctuate.
Yeah.
So you're, go ahead.
So that's what
the timing.
Oh, sorry.
Go ahead, Elena.
You can say something about that in the notes section, and like, if you know that's an occurrence that's happening because of a weather event, you can just say, there was really bad rain. It might have been caused by this. This is why I expect it to be caused by it. And maybe you can go back and check out another time or ask people who have been there more often or something.
Right.
Okay.
You're right.
Gotcha.
If the erosion you're seeing is the result of a recent extreme weather event, you wouldn't want to base the assessment and say that that's being caused by grazing. In this case, this has been this way a long time, and it is primarily due, the sloughing that's occurring and the stuff that's going on in this is primarily due to the grazing pressure that this area is experiencing. So timing is really important. Knowing the background story and what's been going on is really important, and using really good professional judgment.
Gotcha.
And it's always a good idea too to get more than one set of eyes looking at it. I'm a big advocate of taking this, this tool and using it with at least a couple of people. A small team is ideal, especially as you're first getting accustomed to it. Thanks, great question. Thank you.
Thank you.
Okay,
Yeah,
going to the next slide. Oh,
Perfect.
go ahead, Jen.
I'm just, that top right corner and along the top of that's really what answers that question for me. If this had been caused by a major rainfall event and not a management event, there would be a lot more vegetation present at the top of the stream bank. But given how it looks like it's been just mowed, that's what's leading me towards the conclusion that this may be more management based. If I'd come and a stream bank had sloughed, but the grass at the top was doing great, that would lead me to a different conclusion.
Hey, Jed, we're gonna have to giddy up if we're gonna finish this within the time allotted. But you're doing a
No
great
more
job.
questions. All right, sorry. I was just trying to keep it fun. Okay, so this one is a good example of a none to slight. You can see that this is got good vegetation all throughout along the sides. There's no bank cutting, and you even have some brush species shading the stream. And so this would be a really good example of none to slight.
Those are actually native trees, but yes, you are correct. There's a very, very good stable banks. Thank you. All right, I think we're switching gears now, and Elena is going to cover the next couple of indicators. Go ahead, Elena.
Hi, everyone. Okay, so let's talk about a couple more indicators. The first one we're going to talk about is water flow patterns. So water flow patterns are pretty much a path that water takes as it moves across the soil. And you can see them, or they happen when infiltration exceeds what the capacity of the soil is. Like, so there's a massive rain event. If it happens like in the picture, that just means the soil couldn't absorb all of the water. So this picture, it's kind of hard to judge right now because we're looking at a picture from Arizona. If this is in the area that I think it is, many of us would probably think that's like extreme to total. But knowing the area, having looked at some of the ecological site descriptions which they do have there, these would probably actually be closer to a moderate, maybe a moderate extreme, but it can be so much worse. And this is where it's really important to think about with the site that you're in. Make sure that you're not comparing it to the potential of any place. You're comparing it to the potential of this exact place.
Right.
Another thing that's really important here, as we're looking at water flow patterns, and if Carolyn can move on to the next picture, please, is that it's really important to walk around the area, not just stand in one specific spot, because in many of these sites, for indicators such as this one, if you stand in one spot, you might not be able to see the water flow patterns. This happened to us with the picture on the left. We were doing some data collection, and we looked behind us and we noticed that there were these water flow patterns that were actually pretty, maybe moderate to extreme, I think. Didn't see them coming down, definitely saw them going up. Walk around a little bit, get to know your area, and get a different perspective. The ones on the right, I don't know what, I think maybe I would go with moderate extreme. The site looks like it doesn't have a lot of soil stability. You can see the rock, the litter might be sort of shifting around, and there are a lot of those water flow patterns, at least in the picture.
Yes. Yeah, you can see one here running adjacent and then starting to join up with the gully. And if you walked around out here on this flat above this big gully that started to form, you would see that there was more. I just didn't have pictures of them all. Hey, next slide.
Okay, the next indicator is bare ground. So bare ground is pretty much what it sounds like. It's exposed mineral soil. It's not covered by either vegetation, whether it's tire plants or it's live or dead plants. There's no gravel or rock, no visible soil crust, and no litter. So really just bare ground. And again, another one where it's really important to walk around the area, know where you're at, recognize that depending on the site that you're on, these might look different. This spot, like, thinking it would probably be moderate to extreme. The reason it's not extreme to total is because you do have some plants, you do have some live plants there, and you do have litter. So I would actually go further towards moderate to extreme or moderate. And Another thing that's important to understand about bare ground is that sometimes it's natural. So natural bare ground can happen because of ant mounds. It can happen because of rodent holes, rodent middens. And another really important one is some sites are fire adapted in this way. So some sites, and this I know from Arizona, it's like they are known to leave some bare patches so that if the grass starts burning, it doesn't connect. Things like that, it's really important. Again, know the history, know the site as best as you can at that point. If you can talk to other planners who have worked in the area, ask questions.
Yeah, that's a really good point. And in the descriptions of the departure categories, there are some descriptions of the bare ground patches, whether they are large and frequently connected, or sporadic, or small and rarely connected. You can use descriptions like that if you're not incredibly familiar with the site. But for sure, the preferred would be if we had when we have completed ecological site descriptions, it will give you that kind of information as far as what could be expected on the site. Thank you, Elena, for bringing those up. Here's a good example where it's easy to know what should be expected compared to what it is. This should be a guinea grass site, and there should be way more cover on a site like this, right, Elena?
Yes, and definitely not short grasses like that.
Right. But in assessing for bare ground, using the qualitative assessment descriptions of slightly higher than expected or moderately higher than expected, sometimes those descriptions can say it all if you're familiar enough with the site. And again, just make a note as to what influenced your rating and why you chose what you did. Okay.
And this one, I think it kind of speaks for itself. There's not a lot of cover. There's some litter, but again, what are you looking for? And the bare ground patches are as the matrix. If you go to the matrix and you look at it, the extreme to total is substantially higher than expected. Bare ground patches are large and frequently connected. This is all connected. So I think that would definitely go to as extreme to total. And then next one, pedestals and or terrace sets. So you're looking at both at the same time because they are both influenced by wind or water, and it's erosion happening. So the pedestals, they are when soil is moved from the base of a plant. It's pretty much what it sounds like. Again, a little thing of soil below the plant. And then the terrace set is when soil gathers behind or between plants, between rocks, large litter. Say if there's like a log on the ground, you will start seeing soil gather there and start forming these like terrace sets, this like little benches behind it. And this can also happen by water or wind. So here we have pictures of pedestals, and the one on the far left, it's almost maybe half the sizes of the plant. That's pretty extreme. You'd have to look around.
Exposed groups.
Mm-hmm. And you'd also have to look around and see like how frequently that's happening in the area. That's something that the matrix speaks about. And then the one on the right, there you also have some pedestals. They're a little bit shorter, but they're there. And that you can see a little bit more widespread rather than the left picture where we're looking specifically at the plant. On the right, we can see it happening more. And then we're going to look at terrace sets. And so you can see on the top part of that little branch that Carolyn is pointing to, some of the soil is starting to gather. If that was a little bit bigger and this kept happening, then it would be a lot more obvious because water is pushing it towards it or against it.
Yeah, we often find terrace sets kind of on more of the micro scale here in Hawaii. I've not really often come across large terrace sets here, but that is what they look like. So another important thing to note is that terracets are these erosional types of terracets. They are not, sometimes we're prone to look at a steep pu'u or hillside that's got a lot of animal trails that are going across of it, giving the appearance of terraces. Those are not erosional terracets, and those do not get evaluated under this indicator. And those are evaluated under another indicator. And that will be discussed in the guidance document that we will provide.
Okay. Litter movement is the change of location of litter. Again, it can happen by water or wind. Now, what is litter? Litter is dead plant material, but you would not count duff, which is plant material that's already decaying. You would also now not count the movement that is you suspect that has been done by animals or by anything that's not wind or water, if it's really obvious. And the things that you will be looking at as you're looking at litter movement are distance that the litter is being moved. So something like this is if you see a large plant, a large bush of something that you can identify, and you see that there's litter stemming from that bush, maybe like 3 meters away, that has been moved a little bit away. So you can consider that. It also depends on the size of that branch. So in the first picture on the left, you can see how it's the same. It's also a water flow pattern. You might recognize the picture, and you can see how the water has moved this litter from the plants in the back down to the front, and it's like opening sideways. The size of, I mean, how far, the distance that it has been moved, you might be able to see it sometimes, other times not really. On the right, it's a little bit more obvious because you see a bare patch, and that kind of gives you more of a way to view how far everything's moving and the amount of the litter. Where the arrow is pointing to, on the movement by wind arrow is pointing to, you can see the amount of litter there. It's accumulating a little bit, and then if you look slightly down, right above the rocks, you can see a little litter, but it's not too much.
Yeah, this can be a tricky one to assess, especially on our stands that are areas where we tend to have really monotypic plant communities where we don't have a lot of diversity. But that Elena gave you a really good clue where if you do have a sporadic scattering of a plant that is not big, it's not a part of a big monoculture, looking for movement of that litter can often be the easier one, especially when trying to determine how far that litter might have moved. Yeah, good job, Elena. Anything more on this?
I think that is it for litter movement.
Awesome. Okay, back to me. Next indicator we're going to talk about is indicator number 9. It's the effect of the plant community composition and distribution on infiltration. This indicator is clearly tied to hydrologic function, and in fact, it's the only attribute that it tracks to. This indicator rates the effect of plant composition and spatial distribution on the capacity for water to infiltrate the soil within the evaluation area, as well as the amount of time water is retained on the soil surface. Some of the variables that affect site hydrology are above and below ground plant morphology, total biomass production, and canopy cover of the plant community, as well as individual plant species, plant architecture, growth forms, and interspace areas. Infiltration generally is usually highest under trees and shrubs, and then it decreases progressively in the following order, going down to bunch grasses, and then sod grasses, and then bare ground, having the lowest infiltration. When evaluating this indicator, we want to compare the current plant community with the potential naturalized plant community, not a hypothetical pre-contact plant community. So when looking at a site like this, you want to ask yourself stuff like, how is the species composition of the site affecting the hydrology of the site compared to its natural potential? The plant community is described as the species that occupy the site and their approximate compositional amounts. This site in this picture is dominated by a sod-forming grass, followed by some forbs. Although bunch grasses could occur, it is naturally dominated by the sod-forming grass kikuyu. I know this because this is a picture at about 3,000 foot elevation on Kohala Mountain. Is the state of the plant community, however, so the plant community is probably what it would be in its naturalized state. It's naturally dominated by kikuyu grass under the disturbance regime of grazing. But is the state of the plant community affecting infiltration or runoff? Consider what the below ground plant morphology might look like. In this picture, it's a little hard to assess, but anyone that knows kikuyu knows that it looks like it's a little short. It's a little short, and the amount of bare ground that we can see on that pu'u and down here in the foreground is indicative that this has probably been this way for a while. Runoff it's pretty logical to conclude that runoff is probably higher on this site than it would be if there was more cover and taller sod. Considering our matrix, the plant community is comprised of what we would expect, but its condition is probably affecting infiltration and runoff. This site would probably be at least a slight to moderate and maybe even a moderate. Okay, here's another picture of another site. Again, we want to compare the plant community with a potential naturalized plant community, not a hypothetical pre-contact or a plant community that's not exposed to the same types of disturbance patterns. The grassland in the foreground is about as diverse and complex as it will get under its present disturbance regime, that of grazed land. Degraded conditions would show overgrazed pastures with a thin grass layer suggestive of a shallow root system. This, on the other hand, has actually a really diverse stand. It's got bunch grasses of velvet grass mixed in with kikuyu grass. And it's nice and thick. This grass is probably at least 18 inches tall, indicating it probably has a very deep root system. We would not want to compare the naturalized pasture state in the foreground to the native forest state in the background. This site has crossed thresholds and will probably not go back to a forested site without significant inputs and complete change in land use. Considering this site's natural ecological potential as pasture, this site is probably as healthy as it can be, particularly with regard to infiltration. And this site would probably be rated as a none to slight. Here we have a site that is on the line where dry kikuyu grass transitions down to a bunch grass plant community. The plant community composition and distribution is pretty much as we would expect given the environment, and it's probably not impeding infiltration in any way. This site might also rate as none to slight for infiltration based on what we can see. And finally, these two pictures are a really good comparison of really bad for infiltration compared to the potential. On the right, we have what the site could and should look like, a tall guinea grass site with scattered ironwoods. On the left, we have a severely overgrazed site. The plant community should be dominated by tall guinea grass, and instead, whatever guinea is there is 3 inches or less, and the site has a lot of fireweed and broadleaf carpet grass. All these plants are shallowly rooted compared to how it should be. Infiltration is at least greatly, if not severely reduced, and runoff is definitely way more than it would be if it were in better condition. Okay, moving on to indicator number 10. We're almost halfway there, guys. Indicator 10 is soil surface loss and degradation as it relates to wind and or water erosion. Indications of loss can include a loss of thickness of the surface soil horizon, a loss of organic matter, or changes in soil color, texture, and structure. Soil surface loss or degradation is an indication of long-term change in pasture health and often persists after vegetation has been removed, after vegetation has recovered, sorry. This site has evidence of severe soil loss, probably mostly due to wind. We can see evidence of complete loss of a soil surface horizon in the large plant interspaces and the differences in color. This site would probably rate down in the moderate to extreme, if not extreme to total end of the matrix, but would require a little more intense investigation to determine, whether a lower departure rating could be warranted. Here again, we find a large area showing signs of significant soil loss from wind and or water erosion. This site would again be at least a moderate, if not more departed from potential. In this site, we can see some soil loss occurring in the plant interspaces. A shallow soil pit can be compared to the soil description to help determine just how much soil loss may have occurred. And then you would assess based on the matrix descriptions. Okay, compaction. If you have questions at any point, just stop me, okay? I can't see your hands, so just unmute yourself and interrupt me. Moving on into compaction. Compaction layer is a near surface layer of dense soil caused by impact on or disturbance of the soil surface. Compaction layer can be caused by the application of weight or pressure at or below the soil surface. Compaction layers restrict water percolation, plant growth, and nutrient cycling, potentially reducing infiltration and increasing runoff and causing changes in plant composition and production. In this example, was really interesting. We're in the field and we found these funky patterns with the penetrometer when assessing for compaction. In the plant interspaces, we were finding really high penetrometer readings. But when we went into these dying guinea grass plant clumps, we had very little resistance. And in fact, the penetrometer went in no problem. And we found this pattern consistently across this pasture. This has been caused by long-term overgrazing. This is an old sugarcane site, but we were finding this compaction layer fairly within the top 12 inches. And I suspect it's been caused by long-term overgrazing under wet conditions. Remember that moist soils are much more prone to compaction than dry soils, and saturated soils can't really compact, for those of you in Lihue, or parts of Hilo, I suppose. But sometimes compaction can be, you can find patterns like this just with the use of a penetrometer. Using our soil core, we could observe the loss of structure that was occurring in that compacted layer. It's kind of hard to know if this compacted layer is severe enough to limit root growth, as the site is so overgrazed. Plants' rooting depths could also be limited by just a lack of energy and the ability to get deeper. The compaction was certainly widespread, and with the loss of pore space, I would to conclude that it may be limiting infiltration. I would have no problem rating this site at least as a moderate to extreme. It could be extreme, I suppose, if the compaction layer was closer to the surface, or if there was even more exposed ground. Okay, number 12, we're talking about live plant foliar cover. This is describing the live areas of the plant that will intercept raindrops. Research has demonstrated a significant correlation between vegetative cover and the kinds of vegetation with soil erosion, infiltration, and runoff. Plant cover on grazing lands can be viewed in several ways: canopy cover, foliar cover, and basal cover. Plant canopy cover occupies an outline of the projected area occupied by a plant, including the gaps. Foliar cover is specific to a plant part that would intercept a raindrop, and it does not include the gaps between these leaves. Basal cover occupies the least area as a plant crown at the ground surface. It's talking about the amount of cover that's actually also going into the ground. For this indicator, we are interested in foliar cover. As plant cover declines, infiltration decreases. Most studies indicate that cover of 50 to 75% plant foliar and ground cover is probably sufficient to prevent severe degradation from accelerated soil erosion processes. When assessing this indicator, I highly recommend doing a quick line point intercept or step transect using a pin. It's very easy to overestimate foliar cover. So if we did that, according to our matrix, a site with less than 40% foliar cover is rated as extreme to total. Just by looking at this example, I would expect this site very well could be less than 40%, and my transect would either confirm or deny that and give me confidence about my rating. Our high rainfall areas usually have way more than adequate live plant foliar cover. Picture on the right is probably over 95% live cover, making it none dislike. The picture on the left, I'd want to run a quick transect and then rate it appropriately. Now, if a site is covered with brush, do we count that plant cover? Raise your virtual hand if you think yes. would we count the plant foliar cover that is contributed by brush or an otherwise undesirable species? Raise your hand if you think yes. There we go. Everybody's awake and paying attention, keeping you guys on your toes here. Yeah, so the question was, would we consider the plant cover, foliar cover, contributed to a site from brush or an otherwise undesirable species? If you raise your hand, you are correct. Note that this indicator only tracks the soil site stability and hydrologic function. It is only assessing the degree of living plant cover on the site with regards to soil and hydrologic processes. The specific plants that make up that cover are assessed in other indicators. Good job, guys. And thanks for staying with me. Whew. All right, I think we are back to Jed.
Woohoo! All right, we are on to indicator number 13, meaning we're more than halfway there. So indicator number 13 is forage plant diversity. So plant species diversity refers to the number of plant species, richness in their relative abundance, evenness, and composition. From an environmental perspective, the proportionate abundance of plant species, their unique attributes, and their spatial distribution across the landscape are critical features in pasture lands. Many grazing lands are highly diverse with varying soils, climate, landscape features. Individual pastures may need to fulfill multiple functions for producers, such as animal production, resource protection, wildlife enhancement, etc. Therefore, the significance of greater plant diversity may vary from landscape to landscape and from producer to producer. I think you already mentioned this a few times, Carolyn, where depending on the soil types, a monoculture may be more suited to that.
Right.
So on to the next slide. If you haven't already, I think my internet's not great, so you may already be on the next slide.
Yeah, I'm on the slide with the two pictures.
All right, I'm still seeing the first one, but I thought you might be. Okay.
Okay.
In highly productive soils and stable environments, which are at low risk for erosion, where productivity is the main goal, a highly diverse system may not be appropriate. This indicator allows for judgment in establishing and maintaining diversity based on environmental conditions or its diversity of forage species. In accordance with landowner objectives, pasture management involving increased plant species diversity should not simply rely on mixing and planting as many forage species as possible. The goal should be to introduce species that would provide stable protection against erosion and meet the needs of livestock and the farming and ranching operation. So you don't want to just throw something out there to throw something out there, basically.
Right, right. It's important to think about the functions of the plant community. And if you look at your matrix, this is another kind of tricky indicator for us here in the tropics. If you look at your matrix, there are two options for assessing this indicator. If you're comfortable enough with the natural potential of the site, and you can rate it using the language at the top. Language at the top reads stuff like moderate diversity in comparison with site potential and or plant diversity is not optimum with management objectives, okay? Some of you might be comfortable rating a site, looking at it, considering what's actually possible in that landscape, and then giving it an appropriate rating based on that kind of language. But for those of you that are not, use the language on the lower part and determine what amount of the sward is actually comprised of desirable plants and rate that accordingly. If you're going to use that technique or that part of the assessment, that's where my comment in the slide that diverse sites may be difficult to estimate if you're trying to estimate what composition of that sward is desirable versus intermediate or undesirable. So you may need to do a clipping or two and kind of sort them and weigh them roughly just to make sure that they're kind of in the ballpark. There are some table values for approximate moisture content. They're in the National Range and Pasture Handbook. Unfortunately, none of our tropical species are in there. I'm working with the Boise Department Paleo Center to try to create some of those. But if you've done some clipping and drying, you should have a pretty good idea of what the percent moisture content is. And you could always, do a quick clipping, record your wet weights, and then dry a subsample and then modify based on that, and then come back and finish assessing this indicator. Okay, next slide.
Excellent. percent desirable forage species. So the percent of the plant community that is desirable by weight. So this is another one that you would want those clippers for. So we can go ahead and go to the next one. So this is an example of a lot of undesirable species, and these are actually an invasive species, I believe, which would be wild basil, and not sure what the other one is.
Lantana.
Yeah. So the difference between desirable and undesirable may not be that it's invasive. Some invasive species are palatable to cattle and are nutritious and good, but it doesn't necessarily mean that they're exactly what you want. But when we're talking about desirable, we're talking about plants that are palatable, productive, and nutritious. So your undesirables are things that won't help your operation wildlife needs or won't help your forage production for your cattle. Those would be undesirable. They can be native species as well, can fall under undesirable if they aren't suiting the needs of your operation. So that's what you want to define as undesirable versus desirable species.
Yeah, and making ocular estimates of plant weights on diverse sites, again, that can be really difficult. And so again, diverse sites might need to be clipped, sorted, and weighed so that you can be sure that you're assessing, especially in the beginning. You know, I don't think many of you have, well, if you've been clipping a long time and have developed an eye for ocular estimates, great. But if you're not sure about it, a little bit of clipping goes a long way, and you'll be training yourself, training your eye to be able to get better and better at making ocular estimates like these.
Yeah, and if you've been training your eye in Montana, it's not going to be very helpful in Hawaii. All right, on to indicator number 15, invasive plants. I kind of mentioned them a little bit, but invasive plants are aggressive, undesirable plants that can become dominant on a site. And these can actually pop up with help from other invasive species. Like I know on the Big Island, you guys are dealing with an invasive insect that's actually helping the invasive plant species take over.
Correct.
So, yeah. So invasives are a pretty big deal, especially when you're dealing with a diverse ecosystem where just about anything can take hold. And so that's something that you definitely want to consider when filling out this assessment. See if I left anything off. They're going to affect everything, not just this indicator, but they'll be affecting other indicators because they're going to be changing the rainfall patterns. They're going to be changing the soil site's ability. They're going to be changing quite a few things. So this site is wild basil and kulu again. So it's in an invaded state. And when you get into an invaded state, it takes energy and time to bring that back into a desirable state. And so once you get to a certain threshold, that's where you hit those expensive inputs. So through good grazing management, that's what this is supposed to be assessing is what states you're in. And for all these indicators, if you were to catch this when it's at slight to moderate versus extreme, the inputs that the producer will be putting in to control this infestation of invasives will be much smaller and much less time consuming than when you get to a heavily invaded state of extreme to moderate. These are blackberries in Hawaii. When I was in Florida, these were called brickleberries. Not fun to deal with. Things with thorns, and they take over. They kill your pasture production because even if they aren't wiping out the grass species that grow in between them become hard for the cattle to access as well. They become a management issue in several different ways.
Yeah, and this is a picture from an example of a site that's been impacted by spittlebug, and spittlebug is essentially opening the door for all of these other invasive species to come in and take over.
Which is sad because that'll happen even on a well-managed stand. So
yeah,
rather than overgrazing causing that was caused by an insect wiping out the grass. This is gorse, which looks extremely vicious. I haven't yet encountered this, nor do I want to. Another invasive, undesirable species. So they're going to, when you get an invasive species, they're going to affect several things. They're going to affect your plant composition, your species diversity, community dynamics, energy and nutrition cycles. They're going to interrupt everything, and they're going to create their own patterns which help them flourish. A good example of this would be from Montana, cheatgrass. Cheatgrass breeds itself because it changes the nutrient cycle, and it also changes the fire cycle, which helps it spread. So these invasives can be really self-propagating, even with good management.
Yeah. Yeah, and you'll like the descriptions for these. They're very qualitative. Invasive species dominate the site versus are scattered throughout the site, or invasive species are rare. So those make this assessment pretty easy, but it does require that you have a pretty good inventory and a good feel for what the landscape looks like at the broader scale.
And transect, or you could do another step transect or line transect to determine your spread there and the percentage.
Yep. Perfect. All right. I think we're switching gears now to Elena on plant vigor.
I try not to take up as much time. Stick to my script.
Doing good. We're doing good.
So our next indicator is specific to biotic integrity, so plants, and we're talking about plant vigor. So it relates to the robustness of an individual species, but you're focusing more specifically on its reproductive capability. So you're going to look at a site as, next slide, please. Can you move to the next? Okay, thank you. So, okay, if you look at that site, you're looking at the size of the plants and you're looking at the size of the plant parts, focusing again on reproductive ability. If you look at your matrix, this would probably fall under non-to-slight. The first one would probably fall on non-to-slight because you can see like there's a seed head. It looks really healthy. The plants look green. Looks like it's gonna do a good job and continuing to reproduce and continuing the health of the community. So the one on the right, it could be the same, but it's also kind of hard to tell from out here because we can't see the seed heads that well. It would be necessary to walk up and just like look at the individual plants, put your hands in there and like make sure that it's in a good condition. That one could either be if it looks like if the seed heads look like the picture on the left, it could be non-to-slight. If you don't see that many seed heads, you have to think about maybe slight to moderate, because what happens once? Yes.
Or you'd also note how does the plant spread? In this case, that's a California grass stand, and it spreads vegetatively via runners. So you'd also look for evidence of that. And some of our grasses tend to seed more seasonally or at a certain plant age. And so this stand is probably recovering from a grazing event. It may just be that enough time hasn't yet passed, but looking at the stand, I cannot imagine anything that would be preventing this stand from reproducing and expanding itself, and ensuring its survival to another generation. Kind of what we're looking for in assessing.
That was going to be one of my questions, because coming from Montana, where there's definite seasons and you definitely know when grasses are going to be heading out, I didn't know if that you had that as surety here in these climates.
Some of our grasses, for sure. Yep.
That's the other part about this. It's you're talking about recovery after grazing. If you look at your matrix, there's two little paragraphs. So the top paragraph will talk to you about the reproduction abilities of the plant, about what you're seeing, and then the second little paragraph will talk to you about the recovery process. So great recovery would be, well, rapid recovery and all green and healthy green plants. If you go to slight to moderate, then you're talking about light to green and dark plants present. So it's not the same shade of like bright, healthy green. That's another thing.
Yep.
It's pretty explanatory if you look at it.
Yeah. So because soil fertility can have an effect on plant vigor as well. And some plants are more adapted to thrive in more or less fertile sites. So it brings a lot of different dynamics together, but it is pretty straightforward. Good job, Alina.
And this one, I think you'd be pretty happy with that site.
Yeah,
You
that
can easily
grass
tell.
is definitely making sure it's going to be around a while.
Yep. You don't have to worry much about it. I mean, it's obviously a good idea to go in and like look at the leaves, make sure they're in good condition, and look at the colors. The next indicator is dead or dying plant or plant parts. You're looking at the mortality of the entire plant, leaves, stems, branches, roots, whatever you can get your hand on, like look at it. For this, you also have to consider again seasonality, as it has been mentioned, and you also want to think about dormant plants. Make sure it's dead and not dormant. I have committed that mistake, so. And so if you go back to your matrix here and you're looking at this picture, you would probably go with moderate. Moderate is talking about moderate mortality and or dying plants, plant parts concentrated in one or more functional groups. So you can definitely see that something's going on there. You're seeing the gray spots and they're getting a little bit more widespread. You look at the back of the picture and they're still there. The next picture, though, it's slightly worse.
Before we go there, though,
Yeah.
thank you for saying what you said, because it is just a particular functional group that is dying, and that's the bunchgrass functional group, and it's dying due to overutilization. What we have is dying guinea grass plant bases, which, you know, is very, very odd. Other plants are not dying at all. In fact, the sod-forming grasses are quite happy, and they're doing just fine. And so those kinds of things have to get taken into consideration when you're reading these descriptions of departure. You want to really read them in their entirety, and make sure that you're not just focusing on one element on the landscape unless the indicator instructs you to. So the moderate mortality and or dying plant parts concentrating in one or more functional groups makes this fit the moderate just right. But if it was in one or more functional groups, then that might be something else to consider. Here's the next slide.
So this was the picture I was talking about, and it's same thing as Carolyn just said. If you're focusing on one function group, it's probably the trees look really healthy. I think you can see some fireweed in the front, and that kind of annoyed me, but the grass in the back it's a little bit widespread. I don't think it's even close to moderate. It's not extensive yet, but it's getting there, and it's all it's concentrated. That's your keyword. Like it's widespread and it's concentrated.
Yeah. So this is a picture of a pasture being impacted by two-line spittlebug, and it is severely impacting sod-forming grasses where the bug is gotten itself established. It does not affect forbs. It's not affecting the other trees, and so you'd want to take that into consideration. You know, on the broader landscape of this ranch at the time that this picture was taken, probably would have said there's occasional mortality, but you definitely would have wanted to say this is the beginning of a two-line spittlebug infestation, and that we would expect this to rapidly increase. But it's important to remember when you're conducting this assessment, you're conducting the assessment based on the site conditions that you see presently. You can make comments on how you expect it to move in the future, like what kind of trajectory you might be on, but the rating itself should be based on what you see presently. Resist the temptation to assess based on the future of expected future condition. Okay, anything else from you, Elena, on this slide?
That is it. I think that's
okay.
my
Thank you very much. You did a great job. Okay, a couple more and then we'll get to questions again. Litter cover and depth. So this is another indicator that we assess. Again, litter is the dead, recognizable plant material that are detached from the plant, including leaves, stems, and branches. Any plant stems or seed heads that are dormant or dead but still attached to the plant are considered a dead plant part, not litter. Unrecognizable plant material that's either partially or fully decomposed is also not litter, but it's considered duff or mulch. The longevity of litter on a site is highly dependent on current moisture and temperature. Decomposing material is the primary source of organic material for the mineralization of organic matter. Looking at the two examples and considering the matrix, the picture on the left has a little bit of litter accumulated at plant bases, but because there's so much bare ground overall at the site, it's probably at least moderately less than its potential. The picture on the right has good plant density and lots of litter even in the gaps, but it's not excessive. I would probably give the site on the right a none to slight. The potential amount of litter is proportional to the productivity of the ecological site and the pasture itself, as well as weather conditions, primarily for us here in the islands, primarily precipitation. And we would expect more litter accumulation after wet years and less accumulation after dry years, particularly in dry sites like the one that we just looked at. But litter accumulation is also significantly affected by the condition of the plant community. The picture on the left is from that severely overgrazed Guinea grass plant community, and it's at least greatly reduced compared to the potential. I would give that probably a moderate to extreme. While the picture on the right is a grazed Guinea grass pasture with just about the right amount that I'd expect of litter, making it none to slight. Guinea grass pasture, really highly productive. There should be a pretty good amount of litter making its way down to the soil surface. If there isn't, because the plant community is gone, then you would consider whether or not it's got a big departure. A lack of litter on a site that should have some will have a definite effect on the hydrologic function and the biotic integrity of a site. This is, again, an overgrazed Guinea grass site that would probably be a moderate to extreme or extreme to total when considering litter cover and depth. Okay, next one we're going to talk about is the percentage of non-toxic legumes. So legumes are good sources of dietary protein and in some cases energy. However, the risk of bloat cannot and should not be underestimated and can be a major limitation to their use. Not all soils and climates are conducive to the establishment and maintenance of a legume species in the stand, and our ecological site pasture state narratives, when they're available, they will discuss this dynamic in detail. If legumes are not particularly adapted to a certain region, think of your buffalo grass climate zones. It's very rare that you find a lot of legumes there. So if they're not particularly adapted to a certain region, climate, or soils, this indicator can be eliminated from the assessment. Okay, next slide. We don't often come across problems with bloat in Hawaii anymore, but it can and it has occurred in the past, particularly in the upper elevation pastures where white clover is dominant. White clover is probably our highest risk pasture species. We rarely have cattle grazing fields of alfalfa, but we do have it on our plant species list, and it has been planted here before. So it's possible someone could try to plant it and graze it again, and that would be another high risk stand. Management and some available supplements can help to reduce risk, but some producers just don't want to take the risk, and that's totally understandable. Next slide. Here's a picture with an example of a cow that's experiencing bloat. You can see her left side is extremely distended, and this is a picture of a cow that's either died from or is about to die from bloat. What bloat is it's distension of the cow's rumen, the first part of its stomach, due to excessive gas production. In extreme cases, bloat can be fatal. Gas production is normal during the fermentation and digestion process, but if the cow can't get rid of the gas quickly enough by belching, bloat can occur. And if gas builds up faster than it can be belched out, the rumen may become so full that it puts pressure on the lungs and the animal eventually suffocates. So again, certain types of forage plants are more prone to causing bloat. It also matters the amount of that forage plant. A little bit of white clover won't cause a problem, but if she gets into a patch, a big area, and it's all white clover, there could be a problem. It also depends on the age of the plant as far as how prone it might be to causing bloat. And you know, this is an important consideration because the loss of a valuable animal can really upset the economic advantages associated with legumes in the pasture. Legumes can be a good thing because they really increase the amount of protein available on a pasture. Legumes can support a more fertile site, greater soil fertility because they're fixing nitrogen and can benefit the grass. but if it's not done carefully, it can result in an actual loss of an animal, which could completely, upset the whole economic advantage that the producer might have been after. An ideal percentage of legumes based on dry herbage weight varies in the literature between 30 and 60%. I personally think that's a little bit high. Planning legume mixtures in pastures can be done, but needs to be very carefully planned with the producer, and the risks and liabilities should be well known and understood. The percent non-toxic legumes indicator is based on a more conservative approach of a 30 to 35% legume. Okay. Last two indicators. Uniformity of use. In uniformity of use, we're talking about even grazing across a pasture with no areas avoided and under or over grazed. Increasing, and of course, we're not going to have a perfectly straight line, but that's the best I could come up with. Increasing the uniformity of grazing has several positive outcomes. Maintenance of the forage species as a unit, managing the species grazing height, minimizing grazing stress on individual species, and maximizing animal performance and gains, and really maximizing production on the pasture. Managers can increase the uniformity of grazing and protect sensitive pasture by changing the pasture or by modifying animals' behavior. Strategies commonly used to improve grazing distribution are centered around strategic water development or salt placement and often fencing. Here's an example of a high-intensity, short-duration grazed pasture with really good utilization on the right. The paddock was grazed for 3 days, and the only areas avoided were dung piles or the occasional fireweed plant. When you're assessing this, it really helps to be out there assessing it right after a grazing event. This site has the best utilization that you can get as far as uniformity, and so I would give it a none to slight. Here's another example of another intensively grazed pasture. This time this is a California grass stand. And again, there were no areas avoided, nothing really overgrazed or undergrazed. So this would be another none to slight. Here's an example of an uneven grazing, typical of low density, continuous set stock grazing. There's lots of examples on this landscape of sites that are spot overgrazed and areas that are avoided, primarily around the fireweed plants. There's grass inside there that never gets utilized, and the fireweed is really cropping up in places that have been overutilized in the past. Familiarity with your site would help you to spot this. And if you don't have familiarity with the site, find someone in your office or outside your office that can assist you. That's what I'm here for. Elena's available. We're going to get Jed trained up, and there's surely people in your office. If there's not, just give me a call. Here's another example of a guinea grass site that also has very uneven uniformity of grazing. Guinea grass can be really difficult to manage, but in this specific instance, the problem is that there's a lot of evidence of selective overgrazing. Note super low grazing heights in between the old rank guinea grass clumps. This site is grazed very frequently or for very long duration, resulting in this type of pattern. You would want to evaluate this site according to the matrix, which if we look at it, how about we do a show of hands since we're almost done and we're doing really good on time. Based on this picture on our matrix, who thinks this site would be none to slight? Raise your hand. Okay, how about slight to moderate? Little grazed or ungrazed and unconnected patches where forage species are rejected are small and isolated, less than 10%. Okay, how about moderate? Little grazed or ungrazed patches where forage species are rejected are 10 to 25%. How about moderate to extreme? Little grazed or ungrazed patches where forage species are rejected cover 26 to 50% of the area. Awesome. And then extreme to total would be little grazed or ungrazed patches cover over 50% of the area, and rejected patches are generally connected, or uniform use due to overutilization. So if this site the guinea grass bunches had been completely obliterated and we had dead patches like we have in those other pictures, that would be an extreme to total example. but I totally agree with the majority of the group that extreme to moderate to extreme would be very appropriate rating for this example. Good job, everyone. Man, I'm a good teacher. No, just kidding. Okay, grazing and utilization is our last indicator we're going to talk about today. The degree of utilization, how much is grazed off and how much is left behind. Okay, so with this indicator, the general rule of thumb regarding utilization values is right around 50%, which is generally considered appropriate to maintain pasture health and works okay for most of our tropical species. Temporary heavier utilization is sometimes used in grazing systems, particularly more intensive grazing systems, or where rest or deferment is part of the plan. But we want to be careful that this is, if it's done regularly as part of an intensive grazing system, it has to be a nice long recovery period. In this example, the picture on the left is appropriately grazed. You can see a nice kikuyu grass stand right there at the 4-inch stubble height mark. The picture on the right, however, is consistently overgrazed, as evidenced by the lack of any kind of mat of kikuyu grass and an abundance of toxic weeds. All that yellow flower is toxic Senecio. Ideally, you'll assess this indicator in a paddock that had just been grazed right after a grazing event, but sometimes just the state of the pasture can be an indication that this site is overutilized consistently. Here's another example of a really well-managed guinea grass pasture. In this case, all the plants are grazed under high density, short duration rotation. The plants are really never allowed to get super rank, and that stemmy base isn't even allowed to be formed. And this pasture gets grazed very uniformly and to appropriate utilization levels with each grazing event. Continuous grazing pressure is correlated with greater compaction and degradation of soil aggregates, lower infiltration, declining soil moisture capacity, and higher erosion rates. In this case, extreme amounts of feral animals, wildlife consistently overgraze this pasture. This pasture is in an extremely degraded state, and pretty much all of its ecological attributes are hanging on by a thread. This would be an extreme to total situation for sure. Sometimes you will find yourself on a site that has tons of plant biomass. Sometimes they're toxic plants that the animals just won't eat. Take this picture here on the left. Would you say utilization here is excessive? Raise your hand if you think yes. Just one of you think this site is overutilized? Okay. In reality, all these plants are sand mallow and they're completely unpalatable. The animals will not touch it. Every grazable plant has been completely grazed out, or it's down to a fuzz on the soil surface. Long-term overutilization leads to loss of vigor and a complete pasture composition change. In this case, particularly, oops, didn't mean to do that. Pasture is severely overgrazed. Plant height is continually below recommended grazing height for the species. If you can't even find a forage species, you can give this one an extreme to total. And actually, I might add that to that language. If it's all been grazed out and all you're left with is toxic plants, your grazing and utilization is extremely and totally shot. Okay, that's our last one. Just for discussion, this other picture here is again another pasture that should have had a mixture of buffalo grasses and guinea grasses, and it's been completely grazed out and replaced with a very low production sod. And it's all overgrazed. Even for the sod, it's grazed too short. And in this case, we have again a replacement of the forage species with mostly unpalatable toxic weeds, with the exception of a little bit of rat tail in the front there. Okay, thank you all very much. And I'd like to open it up for any questions, comments, thoughts. If nobody speaks up, I have a couple of questions for particular people in the audience. So, okay, she's gonna hate me to do this, but Alyssa Fujii, you guys were my guinea pigs from last year in using the interpreting indicators of range health tool. And I would really appreciate it if you would share your impression of this style of assessment where we're evaluating indicators and evaluating for ecological health, and just what your thoughts are, considering what you just saw and the similar, I'm sure you noted the similarities between this tool and the range health tool and how you feel about it. Would you mind commenting?
Sure. So, being that I don't come from a range background, but I was able to learn a lot on the job here, using the range health indicator last year with Alex. It's like you said, it's very much along the lines of the pasture condition score sheet, and I honestly think it's easy to use. The more and more you do it, like anything else, it'll get easier. It's just gonna take time, and a good example was, I think it was a live plant cover. You're not looking at what is live, you're just looking at is what is live. Not undesirable versus desirable.
Right.
So just small things like that. I think people are gonna just need to be cautious about when they're doing their evaluations.
Yeah, it's really important to understand what that indicator is looking for, yeah, and not make an assumption. And so that's why we're really working hard to make sure you can have a real easy to reference summary for each indicator that'll give you that background guidance just in case you need to refresh, and particularly as everyone is training in this. Yeah, I really appreciate your feedback on that, Alyssa, and I appreciate you and Alex being the guinea pigs last year and really helping me in assessing these tools and figuring out, which indicators really worked well and which ones were really, really troublesome or problematic. I think you really helped us get farther down the road than we would have if we had to roll this out to everybody right away. So I really appreciate the Waimea office for being the guinea pig.
And with indicators like Alyssa was speaking about, it's also sometimes helpful to look at what you're applying this to. So if you're looking at biotic integrity, then you're focusing on the plants. If you're looking at soil, then you care more about the soil aspect of it and how it's affecting the soil or how it's affecting so and so. Yeah,
great comment, Elena. Thank you. And it will take a little bit of time to get used to it and to get to grow your confidence in this tool, but that's what I'm here for. I've already had some conversations with the Kahului office and the Waimea office and the Kealakekua office, so I've got some plans to try to start getting out there. I really want to connect with Hilo and Kahana for Ho'olehua and Oahu, and then Jenna, you guys out in Kauai. Let's set up some time. Jed, also, as I said earlier, he has some experience with this tool. He's just still learning our local conditions and our local plant species, as well as Mr. Gregory, I want to say Gavin, but I know that's wrong. Gerald on Maui also has experience with range health. Would either of you gentlemen like to comment on any thoughts that you have on this describing indicators of pasture health?
Yeah, this is Gerald. Can you hear me?
Yes.
Yeah, I just want to reiterate what Jed had said. This is a really cool tool, but it's going to take a little bit of a narrowing in for Hawaii specific. I've used a lot of rangeland health stuff back in Colorado, but there's a lot of site specific stuff. I didn't know anything about that poisonous senecio, so it's just going to take a lot of site-specific training, which was very similar to what we did, what was needed in Colorado and everywhere else. So I'm really looking forward to getting some training done, though, and seeing this happen on the ground. So yeah, thank you so much for this training, all of you involved, really.
Thank you. Jed, do you have any comments?
I really like the Excel sheet you developed, and I'll be interested to see what the background data that comes out of the rangeland indicators the indicators for rangeland health looks like, as far as how usable it is on the back end. when you pull the data out of the survey 123, so I can steal it and make you one if needed. So
Cool.
if you give me access to that, I'll start taking it apart.
I will definitely talk with you offline about that a little more. You know more about Survey 123 than I do, so we'll definitely talk story some more.
Yeah.
Anyone else have any comments or feedbacks? Was this presentation helpful for you guys, having the local pictures? Anybody have any feedback, or even if you just want to say, I am completely lost, I don't know, give me something. Anyone? Everybody's so shy.
Hey, Carolyn, this is Jason.
Hi,
I just
Jason.
want to say, I was a little, and I printed this out. I was looking, I was like, oh man, this is kind of overwhelming. But going through this was helpful. Kind of, I mean, obviously, I think it's kind of reminds me of the grazing land condition score sheet, so it has that same vibe to it, and ranking it on a scale for each indicator. So I think it'll just take a little bit of adjustment. I mean, this has a little bit more indicators than that last tool, but I think it'll be good for sure.
Yeah, good. I'm glad to hear you say that. This tool will definitely work better and more consistently across the variation that we have in the islands, and that's what I'm really after. I don't know that pasture condition will ever go away. I don't hear that right now. But I just really encourage everyone to be really open to this new tool and learn it. Even if you feel like, well, I'm happy with pasture condition score. This tool is really a lot more comprehensive, and it takes a much broader and more comprehensive ecological perspective on things. So I just encourage you all there. Any other comments? I see some in the comment box. Mary says, I enjoyed the training, learned a lot. Thanks. You're very welcome, Mary. Mandy, very informative. Thanks, team. No problem. Laura, I love the auto-populate. Yeah, good. I'm glad you like that. I can't make the last part of it auto-populate, but the rest of it. Yeah, and just as soon, I would really like to get this in your hands on a mobile platform. I think it makes it just that much easier. And we're really working on that, but it relies on cooperation with some of our partners that we can't always influence their time frame, but we are badgering them about it. So we will get that to you as soon as we can. And in the meantime, this is what we have. I'm going to stop the recording now. Jed, how do I do that?
You press the 3 buttons and then hit stop recording.
Oh, thank you. Okay, there we go. Stop recording.